So I am going to load a calibration here, and this calibration is one that I was actually running in my CSX for a little while. And very quickly I'm going to go over the three types of data that you will see in decal. This first screen you see here is a configuration constant. And these, let me take the disable off here, and these checkboxes can either be checked or unchecked. So this checked would enable the staging limiter, or the two-step miscalibration. Again, enable boost switch polarity toggle. I'm now going to sort these by type. Now this, you saw that the screen changed. What I am now showing is a table. Let me find a better example here. Okay. Here you can see that this gray pane now shows the table and its X and Y axis. The X axis is across the bottom, and it's considered the input, and the Y axis is along the left hand side, and it's considered the output. So basically, when the ECU goes to look up a value, in this case it would be looking up, when it's using this table, it would be looking up spark advance. It says how many RPMs am I at, and what is the spark advance for this number of RPMs. You can see in this small mouse screen here, when I am over the table, that the X shows you the X value that the mouse pointer is currently at, and it also shows you the Y, or return value. So for this calibration, from this table, the ECU would get a value of 24.8 degrees at 1900 RPMs. Again, down here you can see the descriptive data that was in the table file, and it really just makes it easier for you while you're editing calibrations. The binary button. Oh, actually, let me show the last type of data, which is the constants. Let me get one that actually looks like something. Okay. This is a constant that, as the description says, is the temperature that the fan turns on when the vehicle speed is above 45 degrees. So the ECU decides to turn the fan on, in this case at 238 degrees Fahrenheit, when vehicle speed is above 45 miles per hour. You can also see down here in the lower left that it tells you what the current piece of data that you're looking at is. In this case, it's a constant 8-bit piece of data. So now if I were to select, this is an unsigned 8-bit table, and I believe, the other type is down at the bottom. Configuration flags, there we are. And this is a 8-bit flag byte. Now, I'm going to load a 87 Turbo 2. So this calibration I'm going to use to show the compare function of decal. So I'm going to go sort it by address, and I'm going to just take this point, and to edit a table you can click on a point and you can see how it turns red, and you can either move it down or up with the arrow keys, or you can also click on it with the mouse and drag it around with the mouse button held down. So right now I'm really messing with the advance from map cold. So now I've made the ECU remove a lot of advance based upon map sensor value when it's cold. If we were to go to the comparison, I will save this for comparison's sake. And if we go to options and I go to select a comparison calibration, this is the same exact calibration that I just made a copy of previously to demonstrate this feature with. And I say OK. You can now see that the upper left-hand corner of the graph shows that the secondary is in gray, and down here you can see that the secondary calibration, or the comparison calibration, has the beginning of this line much higher. The tables all begin and end with a flat slope. So what this means is that any input value to the table less than, in this case, minus 7 psi, or 15 inches of either water or mercury, I forget which, will return negative 29 degrees. So that means if you're 20 inches of mercury, you'll still get 29 degrees. And the only point that starts changing is when you get to this first point in the table. And then it changes at a rate that's equal to the slope of this line. As you can see by the mouse window down below, as I follow the line up, the amount of spark advance removed based upon the map sensor value is being reduced. And also the end of the tables is the same. So any value greater than the last point in the table will return the value of that point. There are about 4 tables where that axiom does not hold true, and they are the fueling tables, the main fueling tables. Let me see if I could find one. Did I go by them? Bear with me. Here we are. So these tables here, this fuel baseline from map, fuel no throttle, fuel part throttle, and there's a fuel full throttle somewhere. Are the tables that don't adhere to that previously mentioned axiom. The value out beyond the last point of these tables always has a slope. And I guess there's a bug with decal which means that if you were to change this last point here and do something like this with it, it would not recalculate the slope of this line until you went and moved the line just a little bit. Which I can't. There we go. Which I just did a whole lot. So you just move it up and down a little bit and bring it back to where the Y value stayed the same. So if you note the Y value, you can bring it up and back down to where it was. The last thing that I will show, and this is probably a little advanced and doesn't really matter all that much. Oops, it's not the cal data thing. Is this binary